In this video, I will be showing you how to do a two-proportion hypothesis test by hand and using the TI-83. A random sample of N1 equals 555 individuals results in X1 equals 451 successes. An independent sample of N2 equals 600 individuals results in X2 equals 510 successes. Does this represent sufficient evidence to conclude that P1 does not equal P2 at the A equals 0.05 level of significance? The first step is to identify the null hypothesis and the alternative hypothesis, the null being P1 equals P2 and the alternative being P1 does not equal P2. Next, you need to verify that the requirements are satisfied, that the sample is simple, random, and was obtained independently, using this equation to make sure that it is greater than or equal to 10. To find the information to do this equation, we must find p hat of 1 and p hat of 2. From the information in the question, we found that x1 equals 451, n1 equals 555, x2 equals 510, and n2 equals 600. Plug the numbers into the equation for p hat 1 and for p hat 2. We find that p hat 1 equals 0.812613 and p hat 2 equals 0.85. Now with those numbers, we can plug them into the equation to see if the number is greater than or equal to 10. P hat 1 is 84.511, which is greater than or equal to 10, and p hat 2 is 76.5, which is also greater than or equal to 10. And the last requirement is that the sample sizes are less than 5% of the population size. Now that all the requirements are met, we can find the z-value. By hand, the equation is p hat of 1 minus p hat of 2 divided by the square root of p hat times 1 minus p hat times the square root of 1 divided by n1 plus 1 divided by n2. We also must find p hat, which is x1 plus x2 divided by n1 plus n2. Plugging the values in, we find that p hat equals 451 plus 510 divided by 555 plus 600, which equals 0.832034632. We now have each value to plug the numbers into the z-value equation. We find that the z-value equals negative 1.6606, approximately with some rounding error. Since the alternative hypothesis was P1 does not equal P2, this is considered a two-tailed test. For a two-tailed test, if the z-value is less than negative z of a divided by 2, or z-value is greater than z of a divided by 2, we must reject the null hypothesis. With our level of significance of 0.05, we divide that by 2 to find the z-value of 0.025, which, looking in the chart, is 1.96. Now our z-value, negative 1.6606, is less than 1.96. Therefore, we fail to reject our null hypothesis. I will now show you how to find the values using a TI-83. First, hit Stat, go to the right to Tests, go down to number 6 to the two-proportion z-test. Enter in the numbers that the question has given you. This one is 451, n1 is 555, x2 is 510, n2 is 600. Then select the correct tailed test, which ours is 2, and hit Calculate. The calculator then finds each value for you. With a calculator, there is another way to find if we reject or fail to reject the hypothesis. The calculator gives you a p-value. If the p-value is less than a, you reject the null hypothesis. We find that our p-value is 0.089, which is greater than a, 0.05, therefore we fail to reject our null hypothesis. Since we failed to reject the null hypothesis for both the z-value and the p-value, there is insufficient evidence at a equals 0.05 level to conclude that p1 does not equal p2.